Okay, so picking up where we left off with yesterday. What are our two types of stoichiometry that we have? One we've done, one is new. One does start with a C. We've done composition stoichiometry, which would mean what to you? Maybe nothing, but yeah, grams to moles, or you could say percent composition would still be that of composition stoichiometry. And the reason that that's different from reaction stoichiometry is because composition doesn't deal with a what? A reaction, okay? So, and it's one of the aspects that it's that point in time where with the freshmen, we're moving on and we're starting the chemistry section. Yep. Is there, I think the answer is no. And the question would be, is there anything that you wished that you could go back and tell your old self as a freshman that I wished I would have done this a little more? And maybe that was tough because maybe you were at home at that time learning this, okay? But does that sound accurate that I wished I would have paid more attention to configurations, to balancing chemical reactions, to Bohr models, okay, or dot diagrams? And I think maybe with familiar, I can't do that. Help me out, please. Familiarity. I'm sorry. There's just some words I cannot say. That's another one. Yes. So you know. So now you heard it there first. Okay. And I think you would agree that it's important. Is that a question or? Yeah. Yes. Supercalifragilistic makes me alidocious.
Expialidocious.
Oh, so no. Yeah.
Makes me alidocious.
Okay. So what we're trying to explain to the freshmen is this, that when you get on into your assorted career path, okay, especially moving on to a technical school or college or any one of those, even with what we had erased up here, some of these organic reactions, you will not be responsible for organic reactions because that's, in my estimation, more so an advanced concepts, okay? But what I'm trying to explain to them is that the more that you learn here in high school, okay, I'm not saying it's going to be easier in college, but out of your 4 subject areas, okay, let's just go with the presumption that science is up on top. We're just going to say, we're going to stipulate, okay, so science is up there and math is up there on top, okay? So if that's the case, or we could say what's 2, 3, and 4, which would be English. So it's English, math, or social studies. And social studies is pretty vague. Is that government? Is that world history? Is that U.S. history? But after science, what would our presumption be on what is more difficult for you?
More difficult?
Yes. So,
If you answer the right essays, yeah.
okay, one of the things that I think that we do, let's see here, this would only affect 1, 2, 3, 4, and would have last year. What do you 5 have in common? Yeah, had it or are taking it. So when we're, for instance, describing, and what we talked about today, what is the negative feedback mechanism for calcitonin and parathyroid hormone? Okay, so we would want and we would expect you to write that out in full sentences. It's not Mrs. Hemrick or myself just getting our kicks and jollies saying, ha, we're making them write full sentences. Do you think that's important? Because what did you say, the very first thing you said after science? You looked at your possible English. And along with English, you've got literature, and of course, at some point in time, you're probably going to have to do a research paper in college, okay? And I think you're introduced to that in high school. So the length is what, maybe 8 pages?
It is a brand new one.
Okay. Chances are, what do you think the minimum is probably in college?
8 pages. 17 pages.
12.
Probably 10 to 12 pages minimum. Okay? So with that, if you struggle with essay writing, but you're good at science, you've learned everything that is that we try to teach you here in high school, you don't have to put all of this time in learning science because you have a good understanding. Now you take that time that you don't need spending in science, you can spend it on your essay writing. And that is why it's so critical at this level, at least in my estimation. Now, we could say, the old man, he doesn't know what he's talking about. So, and I've talked about this in other classes. If I'm putting organic compounds and reactions up here, how do you know that that's accurate?
No,
How do you know we just don't make that up?
we don't.
No, right, you don't. So are you trustworthy then that on this side of the desk that we're pointing you in the right direction?
Yeah.
Okay. See, and I think by the time you get to be junior and senior year, you really realize that. Some of you probably in freshman and sophomore years, but some of you have come a long ways with that, and just put your trust in what it is that we're trying to push you towards. Because again, the more that you know at this level, the less time you have to spend learning it at that technical institute or at that college level. It just makes everything else much easier. Okay, so in the past, I've always just said, when it comes to sample problems, I just leave that up to yourself to read through, because, and this will probably happen in college, probably more so in algebra class, because I've witnessed it firsthand, okay, where there's a sample problem, so the professor is just writing the work down that's already illustrated for you in the book, just says, well, that's the answer. And rightfully so, you'd say, well, why? Well, I don't know, that's what the book says. But that still doesn't help you out, does it? Because you could maybe figure it out, well, I'm off by a factor of 2. In what you've learned so far and what we've said in class, what might be the biggest reason that you're off by a factor of 2? Something very specific, mislabeling.
Your subscript.
A little more specific.
Making sure your gases have to.
Yes, when it comes to gases and halogens, they're all diatomic. So they have to have a little tubing. It's probably the biggest mistake that we'll see, and you're going to make them. Just accept that. Okay, so that doesn't answer the question. Would you rather read through the sample problems or just work and move on to the practice problems? Okay, so and that's, to me, a good answer. So page 306 then. So one of the problems that sometimes I think that I have, you're not always going to be given the chemical equation, okay? Because that's how we know we're dealing with chemical stoichiometry, or reaction stoichiometry, sorry. That there's a chemical equation that is tailored to that specific problem. And I would think that that's probably that way on, is SAT test, is that even a possibility in South Dakota?
It's a possibility, but it's not widely used, so we don't
Okay.
take it.
So then on the ACT, was chemistry on your ACT exam?
A little bit. It was more like reading charts.
Okay. So that's one of the things, it's a little tough to do at this level, but especially in biology class, that's where we try to really start that interpretation. And maybe a little bit with the A&P class when it comes to that of hormones. How do you break hormones down? They're either what or what? Steroid or non-steroid. And if they're non-steroid hormones, they are what or what? Amino acid based or PP, which is,
Bipolar.
yeah. Aaron, your voice has changed. No, I'm just picking on you. Sorry. But yeah, you would have figured that out. Polypeptide based, non-steroid hormones. Okay. My point is, you're not always going to be given that chemical reaction, and this is what we're getting at here on the top of page 306, okay? It says ammonia, or NH3, is widely used as a fertilizer and in many household cleaners. So how many moles of ammonia are produced when 6 mole of hydrogen gas reacts with an excess of nitrogen gas, okay? So you probably don't know how to set that equation up because you have not been taught this yet. But what does it say? What is reacting with what?
6 moles of hydrogen gas reacts with nitrogen.
Okay? So, and don't get hung up with the idea it says excess nitrogen gas. Okay? We're not too concerned about that. We're just saying that there's an excess to that. So, to me, again, hydrogen is reacting with an excess of nitrogen, and what is it producing?
Ammonia.
Okay, so what is ammonia? Okay? So if we did not go any further, again, we're going to make these mistakes. This is not correct so far. Okay? Which one gets a 2?
Well, hydrogen for sure. Part of that.
It's a gas. Yep.
Yes.
And this is a gas as well. And then, of course, all of the halogens as well, with the exception of astatine or whatever element 85. It's AT. I don't know. Okay. So, and this is to help you out with your setup. What are you starting with? 6 moles of what? Okay. Until you get a really good understanding of this, this is how I would suggest that you do these. Okay. It says in the problem that you've got 6 moles of this. Why doesn't it say grams or something to that effect? Because what's true of gases? The only gas that we can see is if you step outside now. Because the water vapor in your air, in your air, the water vapor in your breath, the moment that leaves, it freezes instantly, and then you see everyone grow. Even I still want to be like a double exhaust diesel or dragon going, blowing all that smoke out of there. Yeah, being a dragon. Yeah. Okay. So, but that doesn't answer. Why don't we say anything with grams here? Well, for one, you can't see gases. So how do you know how much you would actually have? Remember, moles are just counting units. Okay? So it's just much easier to deal with these in moles as opposed to saying we have this many grams. So what is the question asking? How many moles of what are produced? Okay? So of course it's not this because that's nitrogen. So an X amount, we don't know, of moles is going to be produced. Because eventually when we get further down the line, okay, we've got mole to mole problems. We'll eventually do mole to mass problems. Then we'll do mass to mole problems. And then the really long ones is mass of one substance to mass of another. Okay? So I would be led to believe that with composition stoichiometry, this is probably what you're more familiar with because that's where we left off with in chapter 7. Okay, so when you set it up like this, you know, well, we're looking for an unknown substance and how much in moles of this is going to be produced in moles. So once you recognize that, we know this is a 2-step problem, this is a 3-step, this is a 3-step, and then this is the most complex, so it must be how many? 4 steps. Okay? So in step 1, the only place that you can start with is with your hydrogen, okay? And how many moles? Of course, 6, okay? So we've got 6 moles of hydrogen, okay? So with this, you're converting one substance to another. That's not what you're doing in composition stoichiometry. You're always dealing with either the same element or the same compound. Here, you're changing one substance to another mathematically. Okay, but there's probably one thing that I got a little ahead of myself that we should probably do first. With a chemical reaction, you should always do what first? You should always balance it first. Okay, so these are odd and these are even, so we have to get this up to an even number. So how would we do that? Okay, so once we put a 2 there, that gets distributed through the entire compound. So we've got 2 nitrogens. How many nitrogens over here?
2.
Okay. How many hydrogens?
6.
Taking 2 times 3 gives you 6. But we only have 2 over here.
Multiplied by 3.
Okay. Now everything's balanced. Okay. So again, if you have the teacher's edition, see, I can cheat. I can say the answer's 4. See, that's another one of them aspects. Well, just work this out and get this answer. The same professor that I had that would say, are you on the bus and things like that, is the same one that would say, well, I don't think that's teaching if that's how you go about doing things. And he's right. And this was over 20 years ago. Okay? So with that, if we want to cancel out these moles, how do we do that in step 2? Because this is step 1. So in step 2, we're going to change what we have into what it is that we're looking for. Okay? So where does moles of ammonia go? Okay? So if we have moles of hydrogen, how would that be canceled out in our next step?
Oh, right. That's on the bottom.
Okay? And then what would go on top? What we're looking for, which is moles of, okay? And anytime you see a mole over a mole, always look back to your chemical equation, okay? Because when you see this, a mole over a mole, that's where your coefficients come from. So according to this equation, what coefficients, if any, are we going to put into this problem?
2 and 3.
Okay, so where does the 2 go?
On ammonium.
Okay, so since we have a 2 there, we're going to put a 2 here. And what do we have in front of there?
3.
Okay. Now, I used to get all bent out of shape about this, but I think it's just, no offense, but if you use a calculator to solve this, fine, so be it. But some of you, and maybe so, maybe want to take a shortcut and do it in your head. Now that's fine if you don't have any decimal points. There's 2 different ways you can look at this. Take 6 times 2 and divide by 3. Or 3 into 2, or excuse me, 3 into 6 gives you 2, and 2 times 2 gives you, that's what we're supposed to get. Okay? But otherwise, remember, if something is next to each other, you multiply. 6 times 2 is 12. 12 divided by 3 gives you 4 mole of ammonia. Okay? Now, this will be really, really important when we get to limiting reactants, okay? And it was at the, so it would have been 2019, yes, 2019, I believe. Let's see here, 31 and 19 is 50, right. So from July of 1969 to July of 2019 is a span of 50 years. So going back to that time, July of 1969, what was the biggest thing that the U.S. did as far as science is concerned? Landed on the moon. And one of the things I do is when I'm sitting on a mower at the golf course, I have these safety headsets, so I'm listening to conservative talk radio, or it's Belford's in the morning, and he was talking about the moon landing, okay? And one of the things that I didn't know either, besides being before my time, as he's telling this story, he's saying that those astronauts, they weren't certain that they were going to get back off that moon. They had one shot at it, because now when a rocket's probably going to take off from the Earth, or in this case the moon, it's a chemical reaction that has to take place for those boosters to kick in. So again, you're on the moon, but why would someone want to even sign up for that? Because there's got to be some sort of information that says, Buzz Aldrin, John Glenn? Is that, no. Neil Armstrong and Buzz Aldrin, okay? So who's Neil?
Head astronaut.
Who can we pick on? Okay? Is he Neil or Buzz?
He looks like a Neil.
Okay? So Neil, who's Buzz?
Johnny. Yeah.
To infinity and... Oh, that's the wrong Buzz.
That's Tim Allen.
Okay. You're just a toy! All right. So, let's see. I got to think about this. Neil or Buzz? Wasn't Neil the first one to step on the moon?
Yeah.
Do you know how that was deciphered? He was closer to the door.
Yep.
Okay? Aren't you upset that you look at him and say, dude, I wanted to be the first on the moon? You're not. But just think, you're signing up for this mission. You have no idea if you're going to get back to Earth. But you still go and do it anyway. And for some people, you're always going to be known for that. And of course they were. But I don't know if I could sign up for something like that. But again, they're putting a lot of faith in scientists that if that chemical reaction takes place, and in some of this, we're going to get to a problem that does have nitrogen, nitrous oxide, and another gas is called hydrazine. Those have to take part in specific amounts. If you didn't have the right amount of a certain gas in there, that chemical reaction will not take place. So you're trying to say contact for this. Let's start the boosters. You got one shot at it, and of course it worked because they landed back on Earth, but you got that one shot and someone miscalculated that. Yes? Yes. So this might seem like, my gosh, this is just so simple. Okay? And it is, but it's going to get to be a little more complex when, if, for instance, down the road, if we say we've got 12 mole of nitrogen and 6 moles of hydrogen, which one of those is the limiting reactant? In other words, this reaction is limited to what can be produced. It's a way of looking at that is, of course, the old adage or cliche, a chain is only as strong as its weakest link. I was always the weakest link, so that's why I always batted 8th or 9th in the lineup. But that's where the damage is done. Yeah. Yeah, on the bench. Okay. So, questions on this? All right. So, we'll just go ahead and do practice problem number 2. Do you want to work on it on your own after we show you the reaction? This one's really difficult to get the products in. But once we get this process done, do you want to work on it by yourself or together? Still together? And that's fine. Okay, so practice problem number 2. The decomposition of potassium chlorate, okay, is used as a source of oxygen in the laboratory. So how many moles of potassium chlorate are needed to produce 15 moles of hydrogen gas? So you do have a little bit of a clue. So what's happening in a decomposition reaction? In other words, you could say that this is a decomposition reaction if it's going back that way, because synthesis and decomposition are direct opposites of one another. But in this case, we've got potassium chlorate, okay? So when this breaks apart, what clue are you given in this problem?
KCl sticks together.
You're right, but that's not the clue.
The 15 moles of oxygen.
Okay, so you know that what's going to be produced over here. So you know it's producing oxygen gas because it tells you that in the problem, but it doesn't solve the idea of, well, what is left over. So if we got this, so if this has broken off of there, which it has, what do we have left?
KCl.
Yeah, you're right, potassium chloride. Okay. So the next thing you should do is what? Okay, so there again, these are odd, these are even. Okay, what's 2 times 3? So how do we get this up to a 6? Okay. Now, another aspect is don't solve these problems like this. Don't do this.
Oh man. Why not?
Don't be Mr. Keith. I say don't be a Keith. Don't be a Mr. Keith. Or actually, Mr. Crisp. Don't be a Mr. Crisp. We can laugh about it now because I joke with him all the time. Said, well, I knew what I was doing in college. Well, yeah, maybe so, but you probably didn't do yourself any favors in high school. And he knows that. Just ask him. Okay. So we're saying that in the problem, 15 moles of this is produced, correct? So is it asking how much potassium chlorate is needed? So how many moles of potassium chlorate are needed? So that's what we don't know. So an X amount of moles of this substance. Okay? So since it's mole to mole, it's still just 2 steps. So what is your first step? Left, isn't it? You're standing at attention in parade marching or field marching. You always start with your left, correct? Start with your left, right. Start with your left, right. Don't ever answer things like that. Start with your left, correct. Okay, or yes. Okay, so we're starting with 15 moles of oxygen. Okay, there's step 1. So what is our step 2 going to be?
The bottom right, you have to.
Okay, so we want to cancel out moles of oxygen. So we put mole of O2 here, and then what goes on top?
Potassium. Moles of potassium.
Now, there's nothing wrong. You can go ahead and put them coefficients in right away. I would suggest that you don't, but that's entirely up to you. Are you writing this down for your lab mate? That is so nice of you.
No.
Oh, should you?
There's a video.
No, no. Okay. You be nice to your lab partner. She would do that for you. Oh, okay. All right. We'll ask her when she gets back. Okay. So here again, anytime you see a mole over a mole, that's a mole ratio. Look back at your balanced chemical equation. What coefficients do we need?
A 3 on the bottom.
Okay. Coming from this 3.
Yep.
And what goes up on top?
A 2.
Okay? So again, if you like doing things, math in your head, it's fine because we don't have any decimals. 15 times 2
30,
divided by 3,
10.
10.
Were your labels right?
10 moles of potassium chlorate.
Well, that's like half our
Yep, that's what we're supposed to get. All right. Any questions over this? If you are struggling with this, no offense.
But ask.
If you are struggling with this, yes, ask. It is really, really tough to get caught up if we're having problems with this. Okay? So find a classmate. Find a senior other than what we have in here. Those individuals taking organic and biochem, chances are they could look at your notes and say, okay, this is how you do this, and explain it to you as well. Are we, so left side, are we on the bus here? Okay, so I'm doing this wrong. I'm thinking we got all these. Rut row, are we on the bus?
Yeah.
Second row, are we on the bus? Third row, are we on the bus? Emma? You're not, that's all I have. We'll catch up to you next time.